Okay, guys, so sorry about the hitch. This is an example of a system of first order differential equations. Now, I want us to look at how exactly we can go about converting higher order ODEs into a system of first order differential equations like this. You're given, let's say, a second order differential equation. How do you go about converting it so that you can be able to write it in this form? So I hope you guys have already noted the systems of differential equations, and you've noted an example of how exactly a system of first order differential equation looks like. Because the next thing I want us to look at is how exactly you can go about now converting if you have a higher order. Okay, so converting, let's look at converting higher order ODEs into a system of first order. If you have higher order ODs, let's say you have second order, third order, fourth order, and so on, how do you go about converting them or converting that higher order ODE into a system of first order differential equations? So let's look at an example. You're given a second order differential equation, y prime prime minus 5y prime plus 6y is equal to 0. And the question is, convert this second order differential equation into a system of first order differential equations. How do you go about it? Solution. Now, we are going to come up with new variables. So I'm going to say let my x1 be equal to y, and let my x2 be equal to y prime. Since we have a second order differential equation, I'm going to come up with two new variables. So I have x1 and x2. Now, the next thing that I'm going to do is I'm going to differentiate on both sides. So differentiating, what do I get? If you differentiate x1, you get x1 bar. You differentiate y, you get y prime. You differentiate x2, you get x2 prime. You differentiate y prime, you get y double prime. Now, looking at our main equation, we can be able to make y double prime the subject of the formula. So y double prime, so let me rewrite this down here. X2 bar, which is equal to y double prime, is equal to, from the original second order equation, this is equal to 5y prime minus 6y. I've taken all these values and put them on the other side of the equation. Now, we know that y prime is equal to x2 and y is x1. So I can be able to rewrite now the whole of this with respect to our new variables that I assigned. So I can write this as x2 prime is equal to 5. Instead of y prime, I will write x2, our new variable, minus 6. Instead of y, I will write x1. And the other one, the other one is x1 bar is equal to y1. But what is y bar? Sorry, y prime. What is y prime? Look at this. Y prime is equal to x2. So I can simply, let me write it here. x1 prime is equal to y prime, which is equal to x2. so that when we come here, I just write the final answer with respect to our variables. I will have this as x1 prime is equal to x2. So finally, this is my system of differential equations. I can write this as x1 bar is equal to x2, and then I have x2 bar being equal to 5x2 minus 6x1. Are we together? Any question up until that point? So we have this example. So we want to convert this second order differential equation into a system of first order differential equations. So what we are going to do is we are going to assign new variables. So I'll say let x1 be equal to y and let x2 be equal to y prime. Now, differentiating, what do I get? I get x1 prime is equal to y prime, and x2 prime is equal to y double prime. But look at our y double prime here. We can be able to make it the subject of the formula. So let's come and write y double prime is equal to, and y prime here, we can be able to convert this and just write it directly. It is equal to x2 from this. Now, y double prime is equal to minus 0.125 y prime minus y. So we can be able to eventually write this as x2 prime is equal to minus 0.125. What is y prime? Come here where we've assigned our variables. Y prime is x2 and y is x1 minus x1. So we have this 2. Let me write them here as our final solution of system of first order differential equations. x1 prime is equal to x2. This is prime. And then we have x2 prime is equal to minus 0.125 x squared minus x1. And this is our system of first order differential equation that we get from converting this second order differential equation. I hope we are together. You do this example number 3 on your own, and you tell me what you're getting as your answer, please. Let's all do this example number 3. I will call upon anyone to give me the answer. So for our example number 3, we have 2 minus 5 plus y is equal to 0. Solution, converting it into a system of first order differential equations, you say let x1 be equal to y, let x2 be equal to y prime. Differentiating, what are we going to have? x1 prime is equal to y prime, x2 prime is equal to y double prime. But we already have y double prime here. So let me just come and write it here. x2 prime is equal to y double prime. Make y double prime the subject of the formula. We will take this to the other side and divide by 2. So we will have 5 over 2 y prime minus 1 over 2 y. Okay, so we know what y prime is and we know what y is from this original equation here. So I can write this as x2 prime is equal to 5 over 2, y prime is x2 minus a half, y is x1. And initially, we had our x1 prime being equal to y prime, and y prime is y2. So x1 prime is equal to y prime, which is equal to x2. And this is our system of differential equations that we get from converting this second order differential equation. Now, let's look at example number 4. I know the meeting is going on a break in like 4 minutes. I want you guys to come back with an answer for this. This is the fourth order differential equation. Plus 3 double prime minus sin t plus 8 is equal to T2. Now, under solution, this is how I want you to let, so that it gives you an easy way of solving it so that it's all uniform. Let's start with letting x1 prime to be equal to y1, and then x2 prime. We're going to have 4 new functions that we are letting. So let's, because it's raised to power 4. x2 prime to be equal to y double prime, x3 prime to be equal to y third prime, and x4 prime to be equal to y fourth prime. Then go on and rewrite this, and then you come up with an answer. So the meeting is going to end in 3 minutes time. That should be enough time for you to have been able to do it. You just log back in.